change it into the scale. Now how to do it? It's super simple. Look at the screen, click here, you will get three scales: scale, ordinal, nominal. So I want to convert it into the scale. So I will simply click scale, it's converted. Similarly, scale. 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 I'm converting my entire data set into scales. Easy, you just have to click on the item. I think I should sit that way. My eyesight is a bit weaker. Easier for me to look at the screen.
Đèn.
Okay.
Là mờ như chó ấy. Khổ thật.
Scale.
Bật một cái nữa.
I think this position is even better. That I can see both you and screen. Okay. So we are done, I think, yeah? All the variables are in scale. Fine. Now this data set is ready for Jasp. Okay. Now let's go to the factor analysis. So I'll click here. There are three types of factor analysis, right? So I will choose exploratory because that's the most convenient one in line with the kind of research what you're doing. Now what I do, I select, you will choose. Now there are some variables like age, gender, religion, occupation. These are demographic information about your data set. So when you use demographic information, right, now let me start with the descriptive statistics first, right? We'll talk about factor later on. Now let's go to the descriptive statistics, right? We will do descriptive statistics is the demographic information about your variables, your data set, right? So what are the things? Age, put age, gender, put gender, occupation, put occupation, region, put region. Do you see any other?
Education level.
No, that maybe I want to use that as an independent variable for an example, right? But for, see, every study is different, right? So this is the descriptive statistics for me. This is the demographic information in my data. Now when I use demographic data here, it becomes descriptive statistics for you. So now I want to run a test. See, can you see? Descriptive statistics have appeared here. Can you see it? Descriptive statistics. So the most important thing in this table is this missing value. Look at the missing value. Missing value should be always 0. If it is 1, 2, 3, what does it mean? It means that you have missed one of the component or the element in your table, right? So in the descriptive statistics, very first thing is to check the missing value. So we don't have any missing value, which is fine. Mean is also fine. Deviation, other things are fine, right? Now, what happened to this guy? What he is securing? Okay, now let's talk about the statistics. What information we want here, right? It's already chosen, right? So no problem. Now plots, do you want any plot? We can use the descriptive histograms. You see? Now, when you use something like that. This shows the even distribution of each variable, like age, how evenly it is distributed, gender, occupation, region, right? This is called descriptive statistics, which is nothing but your demographic information in your research. Understood? Right. Now let's run factor analysis. Factor analysis, as I said, I am showing you exploratory analysis. Now in this factor analysis, you can see these are all the factors available, right? And this is the variable. So what I am doing, I have converted all my factors already into the scale. So I will choose all. For an example, I am choosing all. You will choose what you want, right? You will not choose the descriptive ones. You will choose your dependent and independent variables. But for the sake of running test, I am choosing all. Okay? Control. So you see, all the variables appear here. Why I am doing that? I want to show you multiple factor analysis. That's why I need more factors. So I am using descriptive too. You guys will use only dependent and independent variables. Okay. Now we need some setting for running this analysis. Now you see, there is an information about method of factoring, right? So what I want you to do it manually, because most of the researchers do it manually. So manually you decide how many factors you want. Most of the studies, they go for 3 factor analysis because that's the most suitable one. What I will do and what I expect you to do, conduct a 3 factor analysis. Now the moment I say 3, you can see factor 1, factor 2 and factor 3. 3 factors based on their similarity are generated by Jasp. Okay. Now when we move further, let's talk about factoring method. Use maximum likelihood. Okay. Then rotation, oblique, Promax is good. This covariance is also, this is also fine, this is also fine. Now let's talk about the output. Do not change. Let this be 0.4. This is the standard value. 0.4 stands here for 40%. So this is the standard value we use. Now what you want? Right? The most important thing here, right? The plots. We want to see the plots. Second, the most important thing in the factor analysis is the test, the KMO test and the Bretweg test. These values are very important. Now we have factor analysis ready with us. Now we will see what are the important things. The very first and the very most important thing is Bartlett's test. Now as you can see, the Bartlett's test value is less than 0.05. See how much it is? 0.001, right? So we can say that okay, our test factor analysis is running satisfactory. But this is not sufficient. We will test the result with the another test too, which is chi-square test. Now let us have a look at the p-value in the chi-square test. This is 0.018, which is again less than 0.05. So with the help of this Bartlett's test and with the help of this chi-square test, we can say that the p-value in both the tests are less than 0.05, which means that we can easily accept the hypothesis. Okay, so this is how we test. These are different things, and this is the most important thing, the diagram I was talking about. This RC1 is the factor 1, this is factor 2, this is factor 3, and these are various subcomponents like age, gender, education level, religion. Okay, so the data I am using here, it's one of the student's data set, right? He has not clearly labeled his variables, so you can't see. Otherwise, when you will label your variables, you will see each component here. Understood? So this is how we do the factor analysis. Understood factor analysis, descriptive statistics. Now let's talk about regression analysis. Now in regression, there is classical regression, Bayesian regression. Based on the level of your survey, the classical linear regression is best suited for you. Now we need to have certain programming for it. Now for the linear regression, we need an independent variable and we need few. We need a dependent variable and we need few independent variables. study, let us say I choose education level, like I said before. Let us say I choose education level as my dependent variable. And the dependent variable has to be in scale, but we have already converted everything into the scale, so that it's not a big issue. Now let me put all the independent variable one by one. Let us say I will put all. You may have multiple variable, you may use it, that's not a big deal. Okay, so I put all my independent variable in this tab. Now it's time to run some tests. Let's go to the statistics. Now if you remember, this is confidence level, right? This is 95%. If you remember, when I taught you sampling method, I was talking about the level of significance and the confidence level, right? This is the same thing, right? And how much we are keeping at 95%, right? Then these are the things which we want in our test, right? About plots. QQ plot is very important, histogram is good. So which value you want to use? P value? No. Okay, this is it. Now to put all the necessary, information, and now this is how the results are produced. You can see this linear regression table, right? Now why this table is used and what this table says. This linear regression table which is also called as model summary, in which you can see the education level is dependent variable. This table shows how nicely your independent variable describe your dependent variables. This shows the goodness to fit, how good this model is, how nicely this model fits into what you are hypothesizing. Now if you see, how do you check that? You check through R square. So how much is R square? 0.259. What does it mean? It means 25.9%. So this model fits 25.9% of your dependent variable. Now let us look at the p value. How much is the p value here? 0.019. What does it mean? It is lesser than 0.05. So should we accept hypothesis here? No. We need additional confirmation. Now from where we will get additional confirmation? We will get additional confirmation from ANOVA table, right? Now let us look at the ANOVA test. In ANOVA, we will again look for the p value of regression. So how much is the regression p value? It's again 0.019, which is again lesser than 0.05. So what does it mean? It means that what model summary described stands true, right? So on the basis of model summary and the ANOVA table, we can say that we accept the hypothesis. That means whatever we have hypothesis, let us say for example, if I wanted to say sky is blue, I started my research hypothesizing that sky is blue, and all my research is about proving that sky is blue. And if I get a value, p value less than 0.05, I can say, okay, yes, I accept the hypothesis. Accepting hypothesis means saying that, okay, what I said is right, hence proved. Okay? Now look into the other values. This is not the only thing. We can see this thing is very evident in the QQ plot and the histogram too. If you look at the QQ plot, you see this is a red line which shows the upward trend, right? And there are small plots. These plots are either on the line or they are very close to the line, but they follow the same flow. They are going in line with the line's flow, right? So which means what? It shows the relationship between the dependent and independent variable. This one is dependent variable, independent variable, and this shows a relationship between them. So this QQ plot also validates our point which we said in the model summary, which we validated in ANOVA table, right? Not only this, we can also validate our point from this histogram. If you see this histogram, it follows a normal bell-shaped curve. You can see the zero. It's not the perfect one, but it is near to normal, right? If you can see the zero, what is zero here? Zero is the mean, and this histogram, sorry, covers the mean perfectly, right? So by that, so hence it can be said with the help of model summary, that is the R square value, ANOVA's p value, with the QQ plot and histogram, we can validate our point that we can accept the hypothesis and there is a relationship between the dependent and independent variables. Okay? Yes or no?
Yeah.
So, where should I put the histogram in? I mean, in that section or in?
It's your choice. It's up to you. If you have sufficient page requirement. How long is your report? What is the word limit? You can put everything, anything and everything in your report. Okay? So you don't have to run all the tests. You can choose based on what suits your table. Okay? Yes or no? Some of the students may not get the exactly same result. They may have a different result. But then you have to, adjust it to the extent when it fits most maximum, when the R square is the most rational one. You will have to do it on the trial and error basis, add, remove, something like that. So it's all about the best permutation and combination.